Okay, hello students. Here I'm making another video. In the last video, I remember doing solving lesson number 3.6, and I went 1 through 12. But the question number 12 was a little confusing because one student asked me how do I sketch this. So I want you to focus only the sketch part. But the thing is, last time if you see the video, that the x-intercept that we got was -6, 0. The y-intercept was 0 minus 6. This is what everybody knows. Then the vertical asymptote, we had two places. One was -7, and the other one was x equals 1. And the horizontal asymptote we got, it was y equals 0. That is the x-axis. The question is, how do we graph this? So I'm going to focus this first few minutes before I go to problem number 13. For this, I need to make a x-axis and the y-axis. So let me use the black color for x-axis. Okay. And then I'm going to use this. Let me take this on the other side. And here. Uh, yeah. So this is x-axis. So I'm trying to take more of minus because there's a minus. I need to figure out where is -1, right? So where is this minus? So first of all, I want to focus on the vertical asymptote, and I'm going to use the red color to use for vertical asymptote. 1 is 1. That means at 1, I'm going to draw a dotted line because at x equals to 1, the function is not defined. So this is going to be all the way down. And also at -7, you can see -7 right here. It's like 1, 2, 3, 4, 5, 6, 7. So I'm going to use this. So this is that you can't have. So I'm going to draw an open circle. That means there is no output when x equals. And of course, here also the output. Then we graph let me use a different color, maybe the blue color to show the horizontal asymptote. So horizontal asymptote is the x-axis. So I'm going to draw dotted right here. So what's happening? What is that you need to notice is the x-axis breaks the whole this points, the x-intercept and the vertical asymptotes breaks the interval into minus infinity all the way to -7. Then from -7, also we have to see that there is a uh, yeah, -7 to -6. So that's the -6 here. So there's a -6 right here also. So -6 can be taken. So that is part of the breaks. There's a small interval from -7 to -6. And this is included. This is included. And again from -6 to -6 to 1. Okay, and then again from 1 to infinity. In other words, what we have intervals. So which are the intervals that the x-intercepts and the horizontal vertical asymptote does is from one of the intervals. We want to know what's happening is -infinity until -7. Then we also want to know what is from -7 and -6. We also want to know what's happening from -6 to 1, and then again from 1 to. So there are so many 1, 2, 3, 4 class intervals that we have to check. So now let's draw uh, the horizontal intercept, that is y, that's already done. Now, how do we know? Okay, I did forget the y-intercept. The y-intercept is using a black color. Y-intercept is this one, which is almost close to 0, -1, right? So that means if this is 1, -1 here, so it will be somewhere here. So that part is where the graph has to go. Remember, the graph has to go there. The graph also has to go at -6 here. Okay. Now I'll start with the point somewhere here. If this is 1, this is 2, and this is 3, and this is 4. What is the equation now? So in the equation, let's plug in each point and see what's going on and how the graph looks like. So if I put a number 2, this 2 right here, over here, so it will be 2 plus 6 divided by 2 plus 7 and then 2 minus 1. And you can see this, that this is positive, This also is positive. That means the graph has to be some up above the x-axis. So only thing the end behavior we know because of the horizontal uh, hor horizontal asymptote is x-axis. So the graph has to go closer here, goes closer this side. And as you go closer to 1, so the graph will be going up like this. And you can easily check. You can use this whole thing and you can put 1 point there. So you can take a point 1.01 and see also. And then you can check. Uh, there's a 0 here. So let's put what's happening here is from 0 to 1. So again, let me clear this out. Now let's take a point. Let's take a point 0 here. Okay, if I put a 0 here, because we want to know whether it's below the x-axis and above the y-axis. So if I put this as 0 plus 6 and down is 0 plus 7, and you can see clearly 0 minus 1. So this is positive, but this is negative. This is going to be negative. It means the graph is below the y-axis. That means you have to begin graphing. So this will start from down here. So this, and remember there's a y-intercept, so it has to go through, the graph is below the x-axis. It has to go here, crosses here, and then all the way, bless me. So this will go this way and go through this, see, this way, and then goes up. Now, now here there's a little confusing between -7 and I can pick a point between here, and that is -6.5, and plug it here. So if I put -6.5, -6.5, and -6.5, and you want to check what's going on for this, is it positive or negative? And let's check that out. So this will be the top will be negative, and the bottom part, this whole thing will be again negative. And this also is, sorry, this is going to be positive, but this will be negative. This is positive, and the answer will be positive. So two negatives makes it positive. Now, if you get confused, better use the calculator and check it out. In other words, all you do is, it means the graph is above the x-axis. So that means this graph will go up like this. So that's how it goes up. And then you want to check for -8. Let's check 1 for -8, what's happening. So if I want to check for 1.8, replace x by -8. So if I plug in -8, -8, and -8, so you end up getting -8 plus 6, -8 plus 7, and -8 minus 1. So that way this will be negative. This will be again negative. This also will be negative. So two negatives makes it positive. So still one negative stays. That means the graph has to be above the x-axis. So that means to the left of -7. So this is how to the left. So because this is -1, so it means below. This means below the x-axis. So naturally, I can't have. Let me wipe this off everything now so that. So what it means is when you want to sketch the graph, we use the blue color. Can it be this? So question is it going to be graph this way or is it going to be one thing, it has to go to this goes to y equals 0. That means the output is almost becoming 0. That's the horizontal asymptote. But the question is up and down, and that's what we checked, that when you plugged in -8, you got the answer as minus. So you got the answer as minus, which is negative. Negative means the graph is below the x-axis, so you can't have above. So your graph will be, so it goes down here and then goes, and this is how you sketch the graph. I hope I made sense. A little bit. So this was the question number 12. And the question was, what is the domain here? So the domain is, so it starts from minus infinity, okay, then goes all the way till minus 7. But remember, you can't take minus 7. So you put open, then again you say union minus 7. You go all the way to this one, that is the 1 here. So that means 1. And then union 1 to plus infinity. So this is the domain. And what is the range? You can say the range is clearly there is no restriction on the y, the graph that we see here, the black. So this part, it goes down to negative infinity, and there's no break. It just continuously goes up. It means it covers the whole y-axis. So the entire y-axis is covered. So it is minus infinity to plus infinity. So let me go directly to now question number 13, another important sketching of the graph. Let me go directly there. Okay, watch this problem. This is problem number 13, and the question is find the slant asymptote and the vertical asymptote. So the question already told why did they say it has a slant asymptote, because if you see the numerator, the degree for the numerator is 3 and the degree for the denominator is 2. So 3 is greater than 2, and naturally you have it has to have. So in order to say because of the degrees, we have to use the long division method, or you can use, let's see, long division method, so that we want to make the degree of the denominator to be bigger than the degree of the numerator. So how do we do then? So let's see. So that means if I have, it's like this. So dividend divisor, can we write it as quotient plus remainder over divisor? So we need to know. Okay, so let's do that. So we need to know what is this quotient function. This is the quotient function, but this time it's going to be of degree 1. Let's see how it is. So start with the long division. So I'm going to start here. The dividend is 9x cubed. Okay. Now there is no square number, still I write x squared plus 9x, right? And then the outside is x squared minus 1. So what multiplies x to get 9x cubed? You can see it has to be 9x. So 9x is 9x cubed. And then that same 9x you multiply here, and you will have to put it right here, 9x. So you get, and then you subtract. So when you subtract, you change the signs. So this was plus, now it is minus, so this becomes 0. And there's nothing here, so it's like 0. And then this one is 18x. So what did we get here is the quotient. So this equals now is the quotient is the 9x plus, and the remainder is 18x, and divide by x squared minus 1. So this is the slant asymptote. This is the slant asymptote. Now, what is the so this is how we find the slant. It means when you're sketching, the line would be y equals 9x. So it means the slope is very steep. So something like this, it has to go through the 0 because it is 9x plus 0. So x-intercept and y-intercept for this line is 0, 0. So that's how it's going to be. But then let's go and check what is the vertical asymptote. How do we find the vertical asymptote? So to find the vertical asymptote, you check the denominator, put it. So vertical asymptote is, how do you put is, put the denominator equal to 0, and that is x squared minus 1 equals to 0. So two ways you can do. One is you just do this way, and you can see this becomes equal to 1. And you put a square root both the sides. So your x is not just plus, but plus and minus 1, because square root of 1 is 1. So you have two asymptotes, that is vertical. One is minus 1, the other one plus 1. So that means here you're going to put, so this is 9x because this is the slant asymptote, and here vertical asymptote is, So this you're going to write down x equals -1, the smaller one, and this is x equal +1. So the moment you get this, the best is we want to draw x-axis. So let's see if this is 1, -1, and this is +1. So I'm going to draw the red one to show that the vertical asymptote is dotted. So it will go this one, and the other one is this one. So this is the vertical. So the first part is you have to know. You also need to know what is the horizontal. So there is no horizontal asymptote because this is what we have to do. So there's a 9x. So what that means is the graph. So here 9x. We'll have to draw another blue one. It means if this is 0 and something, now I'm not perfectly doing here, something like this, the graph. This is going to be a dotted one through kind of thing, something like this. So this is y equals 9x. It's not perfect, but just to understand, it goes through so that's 9x. And the question is, remember, the whole x-axis is split into from -infinity all the way to -1, then -1, all the way to 1, and then from 1 all the way to plus infinity. And by just looking at the function given to us, see this, I already showed that part is taken care. I just want to clean this up to make it nice. Hope otherwise there's too much of stuff on the way. So we want to know what is the x-intercept. Is there x? What is the x-intercept? How do we find that? You put the numerator equal to 0. It means you put 9x cubed plus 9x is 0, right? Which is 9x. You can write it as x squared minus 1. So if you try to do this way and make it equal to 0, and you can see this means either x is 0 or you have x squared minus 1 is 0, and you work this out, you get plus and minus 1. Remember, you can't have x is equal plus 1. We have already seen that at -1 and x equal +1, there is a vertical asymptote. So this is out of question. So x equal to 0, 0, 0. That means the 0, 0 is the so this is the point, the x-intercept. And the y-intercept, suppose you want to know what is y-intercept is, you to find the y-intercept, we put x equals 0. So if I put 0 here, 0 here, 0, this whole thing will become 0. So both x-intercept and y-intercept is 0, 0. That's what that means. Okay, hope that helps. Now, how do we sketch this? All we know is what and here. What does this slant? This is 9x, right? What does that means? Y is 9x. Basically means the question is as x approaches a very large positive number. Remember the y values. The question is, can I? Is this how the graph looks like? That's one question. Or so as x become very large number, the output takes the value almost equal to the blue line. So remember what is the meaning of this is when x becomes very, very large positive number, the y takes the value of 9x. Whatever the 9x takes, so is the same. That's what it means. So the question is this how? But then remember, we don't have no point x-intercept. So it can't cross because the only place where the graph crosses the x-axis is 0. So we can't have this. See, this is wrong. So if this is wrong, then the only other way you can think of is the above. So this side, so it will be like this. So it goes this way, and then as x approaches, let's say x approaches to 1. That means I'm gonna take x approaches to 1. This is 1, right? And to positive side. From right, you're going towards the 1, and you will see the y value, the function here, this function, you can put in the calculator and see. Let's see, you can put maybe 1.01, and you will see it becomes a very, very large, very large, very large positive value. It means this graph will go all the way up like this. And next uh, is how do we know the next part is whether the graph is this way Okay, this is my question. Or whether the graph is this way. Okay, that's my question. Or whether the graph is mm, this way, or whether it is this way is the question. So let's see, we'll have to pick some values to the right side of 0. And so let's pick something to the right. So we need to write down, let's put a point, this is 0.5, and see what happens. So so what I try to do is I want to know what will be when I plug in 0.5. Instead of plugging in here, you can put in the calculator and check. But what I will do is manually, I'll try to factorize the numerator because there's a 9x which is common. So that will give you 9x. This will be square like this, x squared plus 1. And the bottom one will be, this is because this is x squared minus 1, which can be written as x squared minus 1. And use the difference of square, you get x plus 1, x minus 1. And then plug in and see if I plug in 0.5. So this is 0.5. And if I put 0.5 here, square, so this is 0.5. So here also 0.5, and this is 0.5. And clearly, this is positive. This also is going to be positive. This also is going to be positive. But this is going to be negative, see? Because you're subtracting 1 from 0.5. That means the graph is, so over here, from 0 to, so if I want to say this 0 to this one, it is below the x-axis. It means the graph has to be something like this. So it is below, so that this is how it goes down like this. What about negative 0.5? If I put negative 0.5, so this time all you'll have to do is instead of this, you'll have to put negative 0.5. So that will be negative 0.5. This will be negative 0.5, but there is a square. This will be negative 0.5, and this will be negative 0.5. So what you end up getting is this will be negative. And because there's a square is there, this whole thing will be positive. So times positive. Now here it is negative 0.5 and positive 1 will be positive. And in here, this will be negative, both negative, so they become negative. So negative, negative is positive. So above x-axis, it means the graph goes this way and goes up like this. See, and then finally we have to select one of them, maybe -2. So if I put in -2 in place of x, so what do you end up getting? Whether it is negative or whether it is positive. And the thing is, you don't even have to do also. You can clearly see that there is that you can't it cannot be, see, it cannot be, so it cannot be this way because there is no x-intercept here, so that cannot be. So the only option is it has to be the other side. So it means it has to be this side and takes a turn somewhere here and goes to negative infinity. So your question is whether it is really true, and you can always check something, a point here. Maybe you want to take a point, maybe -1.001, and you plug in over here in the calculator. You can plug in here and see it become a very very large negative number that goes down. So I hope we sketch the graph. This is how the graph looks like. So there is this slant asymptote, and that's how it looks like. Hope I made sense. And this is question number 14. And question number 14 is you're supposed to use the graphing calculator is recommended. So a rabbit population on Mr. Jenkins' farm follows the formula. So you're given the formula PT equals 3. By just looking at that, T stands for how many months have passed, and P stands for the population of the rabbits. So the denominator is T plus 3. And you can see clearly this graph. What basically this means is, So easy. The first question they're asking is draw a graph of the rabbit population. By just looking at this, the numerator, that is a degree, t has a degree 1 here, 1 here. So there is a vertical, sorry, there is a horizontal, so there is a horizontal asymptote. So that when the degrees of the numerator and the denominator is the same, so the formula is y equals p over q. Now in this case, this is like your p and the number that multiplies is q. So p over q is 3300 divided by 1, and that's the equation of the horizontal asymptote 3000. So if I want to graph this, mm, let me take this off, and we can put this as x-axis and the y-axis without even knowing the so let's see, this is 3000, 3300, so I'll put this is 3300. So it means maybe this is 1000, this is 2000, this is 3000 and something like. So there is a horizontal asymptote at, let me graph approaches. So as the months pass by, so as x increases, the months pass by, so the graph has to approach here. That's what it means. And if you see in the equation here, if I put t equals 0 here, so we want to know if t equals 0, we want to know what is the x-intercept. To find the x-intercept, let's plug in you need to write when is the numerator is become equal to 0. So to know the x-intercept, put the numerator equal to 0, it is 3300, t equals 0, and the only option is t equals 0, so that means it has to go through this point. And what is the y-intercept? So to find the y-intercept, you have to find, put t equals 0 here. So when you put t equals 0, that means the whole thing, this t becomes 0, so the whole thing becomes 0 over 0 plus 3 is 0. So that means again it is, so 0, 0 is both the x-intercept. So it means the graph starts here, and then the rabbit population goes on increasing, and then it approaches to 3300, but does not become exactly, but uh, the farm has a capacity, it cannot be more than 3300, so it has to be. Then if you see the denominator, there is a vertical asymptote also at x equals minus 3. So if this is like 1, 2, 3, 4, 5, 6, 7, 8, 9. There will be 1, 2, 3. So there is a vertical asymptote here, just something like this. So we are not interested to that. So there is a vertical asymptote here, and this graph, the blue graph, crosses something like this. But for us, the domain is only, what is the domain is where t has to be greater than equal to 0 or 0 on to infinity. So this is how the question was asked. Now, there's one question is asked is what is the rabbit population eventually approaches what number? So this population eventually approaches to 3,300. So that's all you're supposed to write. And that's it. And I hope I made sense to you about is, or you can also put this in the ends in the graphing calculator. So on the graphing calculator, if you click on the graph and the equation, the only in place of t, you're going to put x. So if I graph this and enter, and doesn't make sense here, and look at the graph. So we'll have to do some changes here. So I'm going to make this as maybe 40 months, and the population will have to change to, because the 3,300 is the horizontal asymptote. So we'll have to write this is almost like 4,000. Let's see, 4,000. And there you go, nice graph. So there is this, we start from here. If you want to see below, then I would change this to maybe minus 100, maybe just to make sense. Oh, I made a slight mistake here. Let me go back. So let me click on control, and this goes back, and I want to change this one to minus 100. So that looks beautiful. If you want to see the whole thing, maybe you want to change it to minus 500 and also, and let's see what happens here. And you can see the graph goes down. So what is important is the x has to be positive. So where is the horizontal asymptote? So you can add another equation here and say, okay, y equals 3,300. And then there you go. So that's the horizontal asymptote, which so as the x approaches to bigger number, maybe this one. Let me put this instead of 40. I can't. Okay, let me escape. Okay, now instead of 40, make it 100. And you can see the population almost going to touch the 3,300. So as x approaches to infinity kind of thing, of course, and then the population almost goes closer to 3,300, and your and your question is done. So let's move to problem number 15. So we have three more questions to go. This is problem number 15. So this is a worded problem. Again, we need to use the graphing calculator. A drug is administered to a patient, and the concentration of the drug in the bloodstream is monitored. And you can see there is a domain is t and then infinity. I'll put it. So as the time passes by, how much is the concentration of drug in terms of milligram per liter? So for every liter, so this is every liter of the blood. So this is the bloodstream. So every liter of the blood, how much the milligram of the drug administered remains. So it's given by this function Ct equals, and you can see if you look at this question is, if I write this Ct by just looking at it, we want to know what is the t square plus 4, and so the degree of the numerator is smaller, that is 1, and this is 2. So 1 is less than 2. That means y equals 0 is going to be the horizontal asymptote. So this is the dotted line will be, so this is the horizontal asymptote. As the time passes by, more and more as the time increases, the 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 concentration, that means the concentration of the drugs in the blood, it will go on almost becoming like a zero. That's what that means. But then what happens here in the beginning? So that's the question. But if you see this denominator, so what is the x-intercept here? So x-intercept is to put the numerator is 0, and you can say 7t equals 0. So t has to be 0. So the x-intercept is 0, 0. And what is y-intercept? Is when you put to figure out the y-intercept, again you put t equals 0. That will be 7 times 0 over 0 square plus 4, and again 0. So this is again, the graph has to cross this one. Now, there is no vertical asymptote. So that means if it is going here, now it has to go up somewhere. So somewhere, and it has to go down. So in the beginning, the milligram per liter in the bloodstream of the drugs will go up, and then at some time there will be a maximum, and that's what we don't know. At what time t is the drug maximum here, and then it goes down here, and then almost become. The other side is just for the negatives, maybe it is something like this that will happen. So let's check with the help of the calculator. So the question is, what is the highest? So we need to know the maximum. We also call this as a relative maximum. So we want to know what is the relative maximum here and what time it is. The question is the highest concentration of drug that is reached in the patient's blood. So we want to know the maxima. So maximum can be maximum or minima. So here we are talking about is maximum. So the relative maximum here is also going to be absolute maximum here. So we'll have to, and then the question is, what happens to the drug concentration after a long period of time? It means as the time passes by, if you see the concentration of the drug in the bloodstream goes to zero, that's what this answer, because as the time passes by for a long time, how much concentration of the drug will almost become equal to zero. And there's one more question: how long does it take for the concentration to drop below? So 0.25. That means we need to know where is 0.5, somewhere here. Let's say 0.5. So somewhere we want to know, if I try to draw a line which is y equals or c equals 0.5, we want to know this point here. Once you know this point, then it goes down. So the question is, uh, how long does it take for this to go down? That means we have to find this part. What is this t here? So let's put directly to the graphing calculator. So this was the one that we did previously. So I'm going to take a new one and delete the old one and click on the graphing, and then it says 7. So click on here. You need to know the numerator denominator. Click this and you have, sorry, I made a mistake here. So click on this one and you want numerator denominator. Sorry. So numerator denominator, and the top is 7x. The bottom is x to the power 2 plus 4. So I made a mistake here. So go back, go up 2, and then plus 4. Now we need to see some of the, we'll have to change. Let's graph first of all. What do you see the graph? Let's see how, oh, there it is. I'll take this up here. And clearly you want to know when is going to be. So I have to also make sure I don't need to go too much of up. Maybe 3 will be better here. I don't know. Let's put 3 here and put a -3 here down. So we need more beautiful graph. There you go. And then you can see this tan. I want to have longer period of hours. Maybe I will put 40. I don't know whether it works. And on the left side also, just to see the beautiful graph, I'll put -40. And there you go. And I think 40 is too much. But anyway, but we want to know what is the maximum here. And this side, I don't need much. This I'll make -10. We are not more interested on the left side, but we are more interested on the right side. So to figure out the maximum here, so click on this one, analyze maximum, and there is the peak. Take it to the left, and that's the lower bound, and then go to the right, and there you go. You got the answer 1.75 milligram after 2 hours. So that's the answer. We already got the answer. That is after 2 hours, at 2 hours, there's a maximum concentration of the drugs in the bloodstream per liter. So that's like 1.75 milligram in every liter. Then we need to know when is this going to be below 0.5. So for this, we'll have to click on the tab and put y equals. So if I click here, okay, this is F1, and I want to click. So we want to see when is the concentration is 0.5. So just put a 0.5 here and enter, and let's graph there. So you have this. So we want to know where is this graph touches. So they intersect at a point. So click on menu, analyze, intersection, and now you want to know where does this meet. So click on the left side, go to the right side, and there you go. The answer is, that means after 13.7 hours. So after 13.7 hours, so it will be, so this is exactly 13.7, but then you can put 13.71. So the answer is exactly at 13.7 hours, the concentration is 0.5 milligram per liter. So That means if it is after 13.71, so what I'm going to do is this is, let me see if I can get that. Oh no. So what this basically means, this is 13.7, exactly at 13.7, maybe this one. This is that the drug concentration is 0.5 milligram per liter. So the moment it becomes 13.71, so that crosses, then it is going to be, this will be less, go down. That means on the right side, the blue graph is down. Can you see? So anything that crosses after that will be gram. So after 13 points, so 13.7 is exactly when it is 0.5, but 13.71 will be when the concentration will be below 0.5, maybe 0.49, I don't know, but something like that. I hope that. Let's move to the last two problems and I'm done. Question number 16 has got three parts. I'll call this as A. A graphing calculator is it says so you're supposed to use graphing calculator, but I said no. Why do we need a graphing calculator? If you say give an example of a rational function, it has a vertical asymptote as x equals 8. It means if I write 1, 2, 3, 4, 5, 6, 7, 8, that's where it has a vertical asymptote where the 8 is not a part of the domain. So you will have to put it in the denominator. So if I want to create a function, and here it says px, the denominator has to be x minus 8. The top part could be 1 or 2 or minus 3 or anything, but the main thing is the denominator has to be x minus. If we look at this, where is the x minus 8? The first one has x minus 8. This also has x minus 8. But this means, this basically means it is if you see this part, which is, it says px is x minus 8 and x minus 8. Remember, you can't have x cannot be 8. That means then we can just cross it out to get 1. It means it is the line. It is the line. So y equals 1. It is the 1. But when x equals 8, let's see if it is 8. So there's a hole. It's not defined. So that's how the graph will look like this. There's a hole there, and so that doesn't have a vertical asymptote. So because x minus 8 both up and down, and x cannot be 8, so you can cross it out and get 1. So it is like y px equals, so this px equals 1. The output is always 1. The only thing, at 1 there is a hole there, and you can see, just to show how beautiful this is. If I click here, I hope I'll be able to show. So if I try to put that function, let's say p of f equals, I'm putting in the decimal just to make it easier, and x minus 8, and then divide by x minus 8. And if you do this, you get, so there's a line there. But as you go increase and exactly go at 8, if you see this input is 8, and there's going to be a hole here. So it means it is undefined. That's what. So there is no horizontal asymptote here. I mean, it's a vertical asymptote for this. So, I mean, the vertical asymptote is x equals 8. So for this function, there is no vertical asymptote, but if we put y equals 1 divided by x minus 8, and you can see clearly there is a, and if you pull this out, at 1 over 8 on either side, the graph, see how it is? So there is a vertical asymptote here, which is x equals 8, and you can put dotted like, there you go. So this is the right one. So naturally, when you're working on this problem, the first one is the correct answer. This is the correct answer. Let's see another one. So question number 16, and this is B. Now give an example one that has a vertical asymptote is x equals 8. That means maybe this is 8. So there's a vertical asymptote here. And they're also asking what is the what is the horizontal asymptote at 1, 2, 3? So this is the horizontal asymptote. So remember, horizontal asymptote basically means you have to have the degree, the top degree. Let's see, remember I can put p x raised to m and q x raised to n and plus. So we have like this. That means this m and n has to be the same. They have to have the same. Then we can say it is p over q. In this case, it says 3, so it can be 3, and the 3 could be a lot of degrees up and down. But one thing is we have to look up when is the denominator. So because vertical asymptote is, so the down has to be x minus 8. And if you see, this is the option, is this is one option. This also looks to be correct, and none of them has x minus 8 in the denominator. So out of this, which is the correct one? If you see the first one, so is this the correct? So check, is this correct? And I'm going to write here. So if you see, both have the degree 1, 1. So that 1 and this also is 1. And the coefficient is 3 up and a 1 here. So y equals 3 over 1, and that's correct. So that's the horizontal asymptote. But why this is wrong? So we need to know why this is not correct. If you see, this answer is Rx is actually 3 for x not equal to 8. So it basically means the line is there's a y equals 3. So there is a y equals 3. Let's see, this is 3. It goes like this, and at a there's a hole, and then it goes like this. That's all this means. So this is cannot be the answer because there is no vertical intercept, vertical asymptote, but there's a hole at x equals to 8. Because the moment you have x is close to 8, like 7.99999, and you plug it here, you'll always get y equals 3. Even if you put x equals 8.00001, and still you get y equals 3. Either you approach at 8 from the left side, as approaches 8 from the negative side, or x approaches to positive side, this side. Still you're getting the output will be almost equal to 3. That's like almost equal to 3. And I hope that helps. Question number 3 says, so you are given something, sorry, not that. So you are given vertical asymptotes. These are the two vertical asymptotes. By just looking, if it is vertical asymptote, means the down has to be opposite x minus 1 and x plus 1. And done. And horizontal asymptote is y equals 0. That means the coefficient, the degree has to be up, has to be the same as the degree 1 if it is 1 and 2. And maybe it is x squared. And you can say I can just put, but the x-intercept has to be also 0. So if you want to have the x-intercept, the numerator has to be when y is 0. When you put y equals 0, we want to know when is the numerator going to be 0, and then that's the x equals 5. That means x minus 5. So you should have this x minus 5 in the numerator. So how do we get this? So one thing, you have to get x minus 5 somewhere, right? So again, I repeat, because it says the x-intercept has to be 5, so I put x equals 5 and subtracting 5 get x minus 5. This has to be in the numerator, and that's what I put, and you're done. So if you look at this, where is this one? And you can clearly see this is all the way right here, and you're done. And clearly the horizontal asymptote is y equals 0 because this is x minus 5. And the down one is x minus 1 and x plus 1. So the degree here is, the denominator has a degree 2. This one has degree 1. And so 1 is less than 2. So y equal to 0 is the horizontal asymptote. Next to the last one. And the challenge here in this problem number 17 is, can you write the rational function? Let me call this as Rx or f of x, whatever that is, and you have to have something up and down. By just knowing that it has a dotted line, look at this, they go through 2, right? And this one goes to minus 2. That means these are x equals minus 2 and x equal plus 2 are the vertical asymptote. That means you're adding plus 2 both sides, you get a factor x plus 2, and here you subtract minus 2, you get x minus 2 equals 0. So these are the two factors we can put down here, x plus 2 and x minus 2. But what about the numerator? The numerator helps in finding out the, oh, I'm sorry, this is done. The x-intercept here is x equals minus 5 and x equals plus 5. So by just looking at this, this is x equals 5. That means 5 comma 0 is one of the x-intercept, and this is minus 5 comma 0 is another one. That means if I say x equals 5, that means x minus 5, and this is x equals minus 5 means x plus 5. So these are the ones that you're going to put up here, x minus 5 and x plus 5. And clearly you can use the difference of square formula. The numerator becomes x squared minus 25, because x times x is x squared, 5 times 5 is 25. X times x is x squared, and 2 times 1. So you get this is the beautiful rational function. And you can clearly see that's what it is. You're done. That's all they're asking you is whether you can create a rational function by just knowing at this. I mean, this ends the practice problem for lesson 3.6, and I walked through 12 to 7. I hope that helps, and all of you should get 10 out of 10. All the best.